Mosquitoes cause more human suffering than any other organism on Earth. Annually, over 1 million people die from mosquito-borne diseases, and the economic and societal burdens are vast. Despite the rapid growth in our understanding of mosquito biology and the diseases they vector, mosquito-borne diseases remain a preeminent global public health issue in the 21st century. In this presentation, I'll be discussing the past, the present, and the future of mosquito-borne disease. The transmission of mosquito-borne diseases involves complex interactions between the environment, mosquitoes, pathogens, and often multiple vertebrate hosts. The ecological complexity of these interactions explains in part why mosquito-borne diseases have been so difficult to control. Many mosquito-borne diseases crossed over into human populations thousands of years ago, following the establishment of villages that were large and dense enough to support transmission. Opportunistic feeding on humans by canopy-going mosquitoes resulted in the emergence of new human diseases that were previously transmitted between mosquitoes and non-human primates within forests. Some of these mosquito species adapted to living in villages and began to feed on humans primarily, and a new endemic transmission cycle between mosquitoes and humans emerged. Beginning in the 15th century, paradomestic mosquitoes and pathogens became globally distributed as they were carried around the world by transoceanic voyages. Yellow fever and Aedes aegypti were introduced into the New World, and deadly epidemics followed. For the next 4 centuries, disease epidemics occurred sporadically around the world, and by the end of the 19th century, the link between mosquitoes and diseases like yellow fever was determined, and the science of medical entomology was born. With the invertebrate vector of disease determined, mosquito control measures were developed, which allowed for the building of the Panama Canal, and for a while, the incidence of mosquito-borne disease began to decline. Throughout the first half of the 20th century, intensive efforts led by the U.S. government and other institutions resulted in the eradication of malaria and yellow fever from the United States, and institutions worldwide began to establish vector control programs. However, in the second half of the 20th century, 3 global trends, primarily rapid, poorly planned urbanization, population growth, and increased global transportation, facilitated an increase in the transmission of many mosquito-borne diseases. In many urban and rural areas, poor water and sanitation infrastructure increased the number of mosquito breeding sites, providing year-round habitats for mosquito development and increased mosquito population sizes. Increased global trade and transportation networks have accelerated the spread of invasive mosquito species and mosquito-borne diseases within countries, between countries, increasing the number of people that live in endemic areas. Consequently, over the last half of the 20th century, several mosquito-borne diseases like dengue fever and chikungunya have grown in magnitude. Epidemics of these diseases have grown in magnitude, become more frequent, and occurred in new regions, and also new, more virulent strains have emerged. The current global burden of mosquito-borne disease is staggering. Billions of people now live in endemic areas, hundreds of millions of people a year are infected, and over 1 million die, and the economic growth in these countries is depressed. So, what will the future of mosquito-borne disease look like? World population is projected to reach 9 billion people by 2100. More people are continuing to move into cities where inequity is growing. Insecticide resistance threatens the efficacy of vector control measures. Global warming could increase the risk of diseases in new regions, and new, more virulent strains continue to emerge. However, I am an optimist. Scientific advancement over the last 20 years has made it possible to think that the days of mosquito-borne disease epidemics may soon decline. Vaccines for malaria and dengue are both in development. Genomic sequencing continues to vastly increase our understanding of both mosquitoes and the diseases they vector. Research has shown that bacteria can be used to reduce pathogen transmission. In several countries, field studies are now underway that investigate the potential for bacterial symbionts to decrease the transmission potentials of mosquitoes. And additionally, the development of transgenic mosquitoes or bacteria that produce effector proteins that effectively block transmission are also underway. So overall, I'm very confident that we're going to begin to see dramatic progress towards reducing mosquito-borne disease transmission rates over the next 10 to 15 years. However, even if mosquito-borne diseases are eradicated, mosquitoes are still going to be around. So do everyone a favor and remove all the breeding grounds around your house. Thank you.